Figure 5a germinating wheat seed organs, and after fertilization the ovary will develop into the wheat grain. Wheat is normally self-pollinating, i.e. pollen produced by the anthers land on the stigmas of the same flower. Occasionally, cross-fertilization occurs. 1.2.6 Ripening. The main processes during ripening are the translocation of reserve materials such as sugars, amino acids, and mineral salts to the seed and the conversion of these into the seed tissue and into reserves for the later use of the embryo. Photosynthesis continues as long as the plant has green tissue. The leaves die in succession from the lowest upwards. At the same time the grains develop rapidly. These processes continue until the only living part of the plant is the mature seed. Figure 8 illustrates the tillering and stem extension stages in detail. Emergence is incorporated into stage 1 whilst germination, pollination, and fertilization are not shown. 1.3 Factors affecting growth. Although the inheritable characteristics of a wheat plant are determined by its genetic makeup, the development of these characteristics is influenced by various factors, including climate, soil, fungal diseases, insect pests. Fig.7a Wheat floret showing reproductive structures. Source: Plant Breeding Institute. Fig.7b Drawing from Fig.7a Figure 6 Coleoptile and first leaf. Coleoptile tip of first leaf, plumule, roots. Figure 8 Stages of wheat growth, reproduced with the permission of the controller of HMSO. Stage tillering. 1 shoot, number of leaves can be added, equals braiding. 2 Beginning of tillering. 3 Tillers formed, leaves often twist spirally. In some winter wheats, plants may be creeping or prostrate. For beginning of the erection of the pseudostem, leaf sheaths beginning to lengthen. 5 Pseudostem, formed by sheaths of leaves, strongly erected. Stem extension. 6 First node of stem visible at base of shoot. 7 Second node of stem formed, penultimate leaf just visible. 8 Last leaf visible but still rolled up, ear beginning to swell. 9 Ligule of last leaf just visible. 10 Sheath of last leaf completely grown out, ear swollen but not yet visible. 10.1 Heading first ears just visible, ear escaping through split of sheath. Process continues until all ears out of sheath. 10.5 Flowering occurs from top to base of ear. When completed, the kernel is watery ripe. 11 Ripening. The ripening process sees the kernel move from watery ripe to milky ripe to meaty ripe, when the contents of the kernel are soft but dry. Finally, the kernel becomes hard, difficult to divide by thumbnail. Wheat is now ripe for cutting. The straw is dead. Figure 5a germinating wheat seed organs, and after fertilization the ovary will develop into the wheat grain. Wheat is 1.3.1 Climate. The growth of the wheat plant will depend on temperature, annual rainfall and its distribution, day length, and the amount of sunshine. Wheat is a cool season crop. The minimum temperature for growth is 3 to 4 degrees Celsius, maximum 30 to 32 degrees Celsius, and the optimum is 25 degrees Celsius. Most wheat is grown in the temperate zones between latitudes 30-60 degree N and 25-40 degrees south. In order to reach maturity, the wheat plant requires at least 100 frost-free days and nights. Wheat is either sown in the autumn, winter or in the spring. Winter zone crops normally produce a greater yield than those sown in the spring. In the UK, most wheat is winter sown and has a combined growing ripening period of 9 to 10 months. Wheat is grown in areas where annual rainfall averages from 25 centimeters to 175 centimeters, but about 3/4 of the world's wheat production receives between 37 centimeters and 87 centimeters of annual rainfall. Optimum conditions include a cool, damp period during plant growth followed by a warm, dry period during grain ripening. The optimum ripening period is 6 to 8 weeks with a mean temperature of 19 degrees Celsius. These criteria are not always satisfied in the UK. 1.3.2 Soil conditions. Wheat can be grown on a wide range of soil types. The best wheat lands have fine, close textured soil. They hold water well, yet are well drained and aerated, e.g. loams and light clays. The soil should be provided with an adequate supply of essential minerals, phosphorus, P, potassium, K, and, most importantly, nitrogen, N. The trace elements iron and magnesium should also be present. Planned crop rotation is an important factor in preserving a healthy soil. Crop rotation also gives various nutrients to the soil. A traditional element of crop rotation is the replenishment of nitrogen through the use of green manure in sequence with cereals and other crops. Crop rotation also mitigates the buildup of pathogens and pests that often occurs when one species is continuously cropped. 1.3.3 Fungal diseases of wheat in the field. High yields of good quality grain are essential to arable farmers. Fungal diseases reduce crop yield, giving farmers a smaller financial return per hectare. This is a serious problem for farmers practicing intensive cropping. Wheat can be infected by airborne and soil-borne spores. Fungi produce a thread-like mycelium which penetrates cell tissues. Mildew. This is the most widespread cereal disease in the UK. The fungus affects plants in two ways. Early attacks may restrict root development, reducing the number of fertile tillers and the size of leaves and ears. Later attacks cause poorly filled ears and shriveled grain. In the spring and early summer, new infections appear as small white, fluffy pustules. These grow rapidly to produce a mass of minute spores which turn from pink-grey to brown. Mildew causes premature death of affected leaves. Infection of the glumes often occurs, see Figs. 9a and 9b. Fusarium. A number of related fungi of the genus Fusarium attack wheat plants causing, for example, foot rot, head, ear, blight and pink grain. The EU has set legal limits for two such mycotoxins, DON and ZON, in grain intended for human consumption. UK flour millers monitor levels of these mycotoxins at intake as part of their due diligence procedures. They also contribute data from intake sampling in the early part of the new harvest to inform the overall national strategy each year. Pink grains are occasionally found in wheat consignments. These could be damaged by Fusarium and may contain vomitoxin. Since the mid-1980s, it has been recommended that consignments containing these grains should be rejected. This disease could be confused with the pink dressing applied to seed wheat, which should also be rejected. DON, deoxynivalenol, or DON, is a mycotoxin produced by several Fusarium species but most commonly in the UK Fusarium graminearum and Fusarium culmorum. These species produce Fusarium head blight symptoms in wheat. Fusarium head blight occurs because of moisture during flowering and is associated with the timing of rainfall rather than the amount. ZON, zearalenone, ZON, is a mycotoxin produced by the fungus Fusarium graminearum, which produces Fusarium head blight in wheat. Fusarium head blight is again associated with timing of rainfall rather than the amount. ZON is a potent estrogenic metabolite and causes infertility, abortion, and other reproductive problems in livestock. Minimum residue levels, MRLs, are set for both DON and ZON. In 2020 they were as shown in Table 1. DON, ppb, unprocessed common wheat and barley 1250, unprocessed durum wheat and oats 1750, flour 750, finished products 500, infant food 200, ZON, ppb, unprocessed common wheat and barley 100, unprocessed durum wheat and oats 100, flour 75, finished products 50, infant food 20. Table 1. Maximum residue levels for DON and ZON. Fig. 9a, pustules of powdery mildew on a wheat leaf source, DEFRA, Crown copyright, Fig. 9b, powdery mildew on wheat source, DEFRA, Crown copyright, foot rot, soil-borne Fusarium attacks. Plants late in the season. Symptoms can be confused with eye spot. Lesions appear on the lower leaf, sheaths and stem bases. Premature ripening and lodging may occur, see Figure 10. Ear blight. Fungi attacks the glumes, causing bleaching of individual spikelets. These later become infected with white mycelium and encrusted with pink spores, see Figure 11. Ergot. This fungus attacks wheat and, more seriously, rye. Airborne spores infect open florets, forming dark purple ergots much larger than wheat grains, see figure 12. These contain ergotoxin, a poison which can cause abortion in both humans and livestock. Ergot wheat is not used in flour milling, whilst AIC contracts specify a maximum of 0.01% for feed wheat. Rusts. These fungi are found in most types of plants. Rust attacks cause wheat plants to turn yellow. Spots develop on leaves and the state of the crop is clearly visible from a distance. Grains become small and shriveled, resulting in a low test weight. There are several varieties of rust, usually described by color, e.g. yellow and brown as shown in Figs. 13a and 13b. Burnt or stinking smut. This is the most common form of smut in the UK. The fungus enters the young plant and invades the ovaries, resulting in malformed grains containing fish-smelling black spores instead of endosperm. When broken, they scatter spores over healthy wheat, see Figs. 14a and 14b. Loose or common smut. The plant is infected via the florets. The flag leaves of affected plants are often yellowed and the ear appears as a shapeless mass of black spores. Diseased wheat cannot be used as seed, as the spores would carry over the next generation, see figure 15. Eye spot disease. This fungus produces oval lesions on the stem, which because of their appearance are described as eye spots. The disease attacks the stem near the ground, weakening it and causing lodging. This makes harvesting difficult and reduces yield, see figure 16. Take-all disease. Take-all attacks the roots at any stage of growth. Infection causes stunting and yellowing of the outer leaves. This disease kills the plant, preventing the formation of grain. Ears are often empty and yield is drastically reduced. Affected plants are called whiteheads because of their bleached appearance. This fungus is present in soil. Fig. 13a. Small orange-yellow pustules of yellow rust occurring in characteristic lines on leaves. Source: Dephra, crown copyright. Fig. 13b. Brown rust. Late season infection of flag leaves of winter wheat. Source: Dephra, crown copyright. Figure 11. Ear of wheat infected by Fusarium. Foot rot. Soil-borne Fusarium attacks plants late in the season. Symptoms can be confused with eye spot. Lesions appear on the lower leaf, sheaths and stem bases. Premature ripening and lodging may occur, see figure 10. Ear blight. Fungi attacks the glumes, causing bleaching of individual spikelets. These later become infected with white mycelium and encrusted with pink spores, see figure 11. Ergot. This fungus attacks wheat and, more seriously, rye. Airborne spores infect open florets, forming dark purple ergots much larger than wheat grains, see figure 12. These contain ergotoxin, a poison which can cause abortion in both humans and livestock. Ergot wheat is not used in flour milling, whilst AIC contracts specify a maximum of 0.01% for feed wheat. Rusts. These fungi are found in most types of plants. Rust attacks cause wheat plants to turn yellow. Spots develop on leaves and the state of the crop is clearly visible from a distance. Grains become small and shriveled, resulting in a low test weight. There are several varieties of rust, usually described by color, e.g. yellow and brown as shown in Figs. 13a and 13b. Burnt or stinking smut. This is the most common form of smut in the UK. The fungus enters the young plant and invades the ovaries, resulting in malformation.